And we are delighted to begin the official conference program with our opening keynote speaker, Yasmin Kafai. Yasmin is professor of learning sciences at the University of Pennsylvania. She is a researcher and code developer of online tools and communities to promote computational participation, crafting, and creativity across K-16. Please give her a warm welcome.
Does this work? Great. Well, thank you very much. Well, thank you very much for the invitation to speak to you today. In particular, Chris Stevenson, who has been on my case for quite some time to come here. But I think it couldn't be a better moment to talk about the topic. And what I want to do today is kind of look at where we are in CS education K-12, also where we have been and where we should be going. Because as you all know, more so than anybody else, lots is happening in the last few years, from the reports on how few students are involved in computer science based on AP numbers, but also on many international initiatives happening. What's happening here is not happening alone, it's happening across the world. And many talks about what actually should we teach and how should students learn is really at the core. And you are the people here who are going to make it happen. And for this talk, there's only two things I want you to remember. Everything else you can forget. And no. One thing I want to focus on is this conversation around computational thinking. And you probably heard this term now up through your nose. I mean, it has kind of become the rallying cry for brain computing back into school. And what I want to try today is to convince you, yes, computational thinking is important, but maybe we should be focusing more on computational participation. And what I will do in my talk is explain on why this shift is important and what it could look like. And the second piece I want you to focus on is equally, I mean, there's a lot of focus on broadening participation in computing, in giving more access and making more students knowledgeable, in changing students, teachers' perceptions of computing. And all of this is important and has driven a lot of what you're doing here, both on the school, state, and policy level in the last 10 years. But I think it's time now to move beyond broadening participation into deepening participation. Broadening participation is still important, but we need to kind of look ahead what the next challenges are. So two things, computational participation and deepening participation will be the core points what I'm trying to do. So I want to talk first about computational thinking. And I mean, you are an audience. I don't need to tell much about what computational thinking is. Since 2006, when Jeanette Wing wrote, a short piece in the Communications for the Association of Computing Machinery, which is kind of like the big journal for the professional computer scientist. And she was kind of trying to do it to kind of identify what is the core of computer science? What are the contributions of computer science beyond its original? And I think for some reason, it's not that people never asked this question before, it really struck a chord. And what has happened now is it kind of gone beyond academia. It really has become the call for thinking on how we should introduce programming and computer science at large back in school. And a few years ago, we actually had 2 workshop meetings. I was part of this. We were kind of struggling, to come up with a definition. And let me rob you of any, hopes. We didn't come to an agreement. So there really is no agreement beyond Janet Wing's definition. And we also tried to identify what is the pedagogy around computational thinking. And I think a lot of what's captured in these reports is also captured in this video I'm sure you all are familiar with, which came out last year by Code.org. And it had a whole array of very famous people, not just in technology, but also in media, music, and other places. And one of the quotes actually came from Steve Jobs. It said, you know, everybody in this country should learn how to program a computer because it teaches you how to think. And I think when we hear computational thinking, this is what most people kind of associate it with it. It's this focus on thinking, on what kind of happens in your head, in your individual. And there's nothing wrong with this, but I think it's a very narrow view, a very narrow definition of coding. And what I would like you to think about is that coding is much more than just thinking. Because if we think about coding as a literacy, most of the time we think about it, I mean, as adaptation as something functional. And I would argue many of the examples in yesterday's workshops in all the kind of curriculum standards focus, what do you need to know? What kind of programming concepts, what kind of practices need you have? But there are two other aspects of literacy we never really hear much in these conversations. And the second one is literacy as power. It's actually the political aspect. We are becoming literate, not just to kind of learn certain things, but in order to participate in society, to influence decisions. And then there is a third part we even hear much less frequently about. It's literacy as grace. And that's about kind of personal fulfillment. You know, we're writing letters, I mean, to vote somebody, I mean, a marriage proposal. I mean, nowadays, of course, nobody writes letters anymore. You will compose a 140-character tweet to accomplish the same thing. But I think when we think about literacy, we not only can focus on the functional aspect, on the adaptation, we also need to think about what is the larger social goal behind it, and what are also personal applications of this. And this is not something I came up with. Sylvia Scribner is a very well-known literacy scholar, and she actually did not write this up for coding. She talked about this from reading and writing. So I did some work in kind of trying to identify on how we can kind of translate when we think about computational thinking and kind of casting a wider net. And so when we think about adaptation, yes, we need to focus, that kids have a basic understanding of the functionalities that underlie interfaces and technology, about the programming concepts. But we also need to understand that beyond code, it's about empowerment, to understand why are the things on the screen made the way they are, what needs to change, what can change. And then also, if you look especially at your students, they all have computers in their pockets. Very powerful machines. And so on a personal level, they're already all very heavily engaged in using technologies and for very personal purposes to communicate, to connect, to socialize with each other. So also, how can we kind of leverage getting code into kind of a more personal domain? So the argument I'm trying to make is, yes, we need to focus on computational thinking, but we need to expand it to computational participation in order to capture these political and personal purposes. And in order to kind of get you there, how I arrived at this kind of conclusion, I want to take a step back 20 years ago. And I know, looking at the audience here, there are a number of people who were actually there 20, 30 years ago, which was the first golden age of programming in school. Maybe I shouldn't call it the golden age, but many of you might not remember that we actually had a fairly, nationwide effort of kids programming in school. Most of it probably badly. Lots of discussion which kind of programming language to use. And a lot of this was kind of impacted by Seymour Papert, who also was my advisor, and who created actually a model school in the late 80s, Project Headlight. And I want to show you snippets from a video, which is now 20 years old, so you will apologize the bad quality. And you will also recognize the machines were 256K machines. They were obsolete the moment they hit the market.
It's demo time for parents at the Hennigan School in Boston. He will ask you a fraction problem. If you get it wrong, you will become mentally deformed.
I don't know what's wrong with it.
After months of work, the 5th grade students are showing off the computer games they created. Even the principal is here to take a try. The children are using the programming language Logo, invented by this man, Seymour Papert. As part of a bold MIT Media Lab experiment known as Project Headlight, Papert, his research team, and the Hennigan teachers are developing methods to put inner-city children in charge of their own learning. Instead of using purchased software like most schools, Project Headlight challenges the students to use Logo to create their own software.
How did you decide what to put in your messages when you get it right? Well, they had basically all the same. I don't know. I just thought it'd be encouraged them if it was right.
What do you say when they're wrong?
That's wrong, try again.
In the design process, they become expert programmers. They draw, manipulate shapes, even guide a skier down the slope. And like all the students, this one is built in a surprise. When the skier hits a bald spot, a fraction quiz. No run-of-the-mill video games. These are designed to teach mathematics. Abigail has chosen to design her fraction game around the Greek myths.
You want to go to the home of Zeus, but the map was ripped up by the Greek god Hades. All the Greek gods and goddesses have a fraction in the map. You're to go to the gods and goddesses one at a time.
Her toughest challenge involves allowing the user to choose an answer from the quiz. She's had to learn the hows and whys of the ifs and thens.
The hardest thing about this is making the program for what your answer is to the fraction problem. Like, if you push A, then you do this, and then if you push B, then this happens, and C, then this other thing happens. So it's really hard.
The fact that a 9-year-old is learning such sophisticated programming concepts is a testament to Project Headlight's success. And for Abigail, the command of the computer allows her to devote her attention to what she really enjoys. Designing a Nintendo-style interface and creating a compelling story around the gods. Ginny has designed her fraction game around a spider web. Like her classmates, she's learned advanced programming. She's also learned the advantage of producing her own game.
Because you make your own game and you can play it anytime you want. But in Nintendo, this right here, you don't have to buy it because you're the one who's making it.
With Nintendo as a model, she's even designed her own game box.
Like, at first I didn't know how to design the web. And so the art teacher helped me and I designed it.
In fact, as part of the project, all of the children package their games and promote them with an ad campaign. These integral activities make this project unlike any textbook exercise. The students here are designing a real product from start to finish. And through the process, they learn about every advertising medium. They even produce TV commercials.
If you play this game, play it good, you may grow up to be like Ronald Reagan. Wow.
Mission Town is awesome. It's spooky, it's scary, and it's exciting. And it's by TCA. Awesome.
So I think you get an idea. Remember, this is 23 years ago, and this was actually coming at the tail end on when computers and programming were in school then. It was promoting a different vision on how we should think about teaching code. It wasn't about teaching concept. It was about integrating them within a context, and it was inspired by Seymour Papert's work. And I want to kind of do a really 2-minute short review, because many have forgotten that the ideas which were promoted in this book very much didn't just hold true yesterday, but also can inform on how we think about programming. And I think one of the important parts is that, he always thought about programming as something which is personal, and one of the core ideas some of you might have heard this objects to think with. If you think about object-oriented programming, the connection is really clear, is that we're not just learning code for the sake of coding, but in order to kind of make artifacts. And these artifacts, I mean, you create, whether it's a sandcastle, a program, are of personal relevance. Then another key piece in his book was about what should a learning community look like? And to that he actually turned, and many of you probably watched the soccer games, to the samba schools in Brazil as an example where you have, a very kind of collaborative learning communities, because for him, learning wasn't done in isolation, it was part of a larger social enterprise. One of his examples was always when you learn a foreign language, the best place to go to learn it is to actually go into the country and live there to experience the full facets. So aside from the personal, that what you create has personal relevance, you also need a kind of social component. And I think many of you know in your classrooms, it's not just about the individual learner, it is also about the community, the helping with each other, the collaboration. And lastly, he also talked about the culture. And this is the part I think many of you are familiar with as teachers, because for many, for the last 2 decades, we really have not valued computer science teachers and education, and more problematically, we have thought that it's only for very particular students, mostly white male boys. And so the culture we create in which computing takes place, how we think about the approaches or how programming should take place are equally important in order to help us in this shift from computational thinking to participation. And I want to take you through 3 kind of shifts we can accomplish this. And the first one I already indicated. Over the last 20 years, we had a lot of emphasis, and there are probably hundreds, if not thousands, of studies which have looked at how difficult it is to kind of program in loops or conditional statements, operators, all these things, and understanding what is kind of difficult. And there is no question, learning to code is not easy, no matter what people say, especially if it gets a little bit more complex. And in some ways, we also have tried to create graphical programming language. But I think this is just a focus on code. And what we learned over the last 20 years, in order to make it personal, we need to actually think about code and context. And I think actually the workshops, many of which you participated in yesterday, are examples of the many ways in which coding can be contextualized. The applications you can create, whether it's simulations, whether it's working with big data, whether it's about art, music. I mean, you can kind of think about multiple ways. For most kids today, the entrance into technology is through the applications, through the apps. And there is no better way to kind of make it personal by thinking about designing them yourself. So this is kind of the personal component. What about the social component? Another thing which has happened over the last 20 years is this overly emphasis on designing programming tools. Logo alone has probably over 200 variants, and there's still more created. And don't get me wrong, I think it's very important that we think about how to design programming languages, in particular for beginners, that their languages might look different than those which professionals use. But we have kind of had an overly technical focus on the tool, and I would argue what the recent research shows is that we really need to focus on the community. And I think Scratch, which I helped to co-develop with Mitch's team at MIT, is a great example because it was conceptualized as a programming tool, but when we released it, it came with a community. And nowadays, I mean, you have millions of kids who kind of submit projects. I mean, on a daily, on an hourly basis, you have hundreds of projects submitted, which illustrate that kids themselves don't think about coding as an isolated activity. They want to share their designs. And so my recommendation is, yes, tools are important, but think about them also in a social context. And your classrooms are social contexts as well, whether or not they're connected to a larger online community. And finally, there is a cultural move. And this is a kind of little pun from scratch to remix, but we often think about of programming starting from scratch, from the blank page. But nowadays, when you look what professionals and others are doing, they actually go online and check whether somebody else has already written a procedure or a script they can repurpose. Now, this kind of copying, is not kind of very well liked upon in school because it looks a little bit like cheating, you didn't create on your own. But again, I think what we have seen in the Scratch community is that, the remixes are a very popular entrance gateway into programming for people to get started, to appreciate how things are made. And Andres Monroy Hernandez, who actually created the Scratch community, his research focused on remixing and the different forms, and that there are some remixes which are just copies and others which actually kind of engender more creative productions. So I think these three pieces are really key if you want to think about programming as a personal, social, and cultural aspect. And I kind of recommend, an extended definition of Jeanette Wing. I'm not taking away from computational thinking because the focus on problem solving, designing system, and understanding human behavior is key, but we need to think about it in a social and political and personal context in order to make this a reality. Otherwise, if it's just code alone, it's not going to happen. So if computational participation is so important, how can we get there? And so my second part is actually about looking at this larger effort of broadening participation to moving into deepening participation. And I identified 3 different areas on how we can think about it. And access, activities, and communities. And the first one is about access. And you can know that, it's no question that we have a great imbalance on who is participating right now in computing and what impact that has, who takes a P exam, and then also when we later come to the college and university level and to the professional context, how few women and minorities are there. So I think we need to kind of think about new ways, create new communities in which there's access. And I have to say, I put here girls code and black girls are coding. I have been very much an aficionado of mixed classrooms, but now I think it's time for an intervention to create even targeted communities in order to broaden as well as deepen things. And here is why this is important. And I'm going to share with you now some recent findings of the research we have done on the back end of Scratch. So Scratch, as you know, is a fairly vibrant community over the last 7 years. It has actually grown exponentially in terms of just actually in the last year or so, the number of registered members and projects has nearly quadrupled, and it's going so. So we were actually wondering, because you all probably heard from Mitchell Resnick and others, very compelling case studies of what kids were doing on Scratch, how they formed communities. But does this really apply to everyone? Scratch is open and free to everyone. Does this mean everybody is coming? So 2 years ago, we actually selected from 20,000 users who logged in January, 5,000 random samples. So there was no cherry picking going on, not the favorites and the people who do well. And we just simply looked on what they were doing on the site and their projects. And so the first thing you see, there's a really big divide between the creators, so people actually who post projects, and those who just hang out on the site. Now, there's nothing wrong with hanging out, because we all understand if it's a social enterprise, it's not just about coding, it's also about sharing, commenting, and other pieces. But if you look how the creators kind of divide themselves up, then even within those groups, participation is actually not equal. We have a group which we call the high network group. They're the kids who actually do the most. And they're at most 5% of those 45%. Everybody else is kind of doing a lot of things, including posting projects. And then, if you look over the 3 months time period, you will see that things shift around. So if you come in January and post a project and do something, it doesn't mean you'll do this in February and March. You might actually move away, not going at all at Scratch. And there is this really small sliver of high network, high project people who are kind of online. And this is just about participation, counting numbers. Now, another thing to look at this is, what are they programming? Maybe, they only do a few programs, but they're very rich. And so right now, as a proxy, and I realize this is a kind of, very limited view, we just kind of looked at the kind of concepts which were represented in those projects. And what you see here is actually something which is not very surprising. There is a class 1, which is, 58%, and they use a little bit of loops and not much of else. And then on the top, you have the high users, which are the class 4, which are 8%, who use much of everything. So what we have here is that some concepts obviously are easier to use, and looping seems to be one of them, whereas conditionals, random, anything which involves variables is much harder to come by. But what is not incorporated in this graphic is here that girls are not found in the first group. In the group high up there. They're mostly at the kind of lower end of computing, as is it's true for the newcomers. Now, it's not very unusual for people who just come to the Scratch side. We wouldn't expect them to do anything fancy. But, we know that participation is not equitable even in a Scratch community. And the reason why I'm sharing, these are actually an analysis which we literally just finished on Sunday, and still ongoing, that there is a big difference if we look at increasing participation by choice, which is Scratch, when people come and go, or whether we go by design, is what you do when you are in a classroom. Because one of the big leverages is, in terms of joining, all your classroom students are going to be there. Now, that doesn't mean they're all going to participate. We do know, and also this also, by the way, applies for the girls. In schools you have, and minorities, you will have them present in your classroom. Now, we know in terms of equity that it's not sure, even if you have 30 students in your class, everybody is going to be interested, is going to participate. But your chances of creating a number larger than 5 are much higher than what very likely we will find in the Scratch community. And I think I'm not kind of bashing Scratch. I think it's a fantastic environment. It's freely accessible. It has been translated into multiple languages. So people across, the continents can participate and join together. But we need to realize, if we think about making computational participation a reality, we can't just rely on out-of-school efforts. We need to take into account what happens in school. And by the same token, I would argue, putting all the onus on teachers just to focus on what happens in classroom is also not enough. We need to take into account that there must be other venues where you can enjoy, practice, and participate in coding. It's just like reading. If kids were to learn reading just by the hours of instruction in primary school, very few people would become fluent readers. That's why we have big reading campaigns where we ask parents to read to their children. People come to the library, created a whole network and ecology to make people readers and writers. And likewise, if you want coding to become a reality in the 21st century, we can't just limit it to the classroom, but you are the important leveragers, because just relying on the outside, as we learned, even if the numbers are large, if they're millions, that will not happen. So how can we do this? One important thing is, in terms of, we also need to deepen activities. And I noticed, here in the workshops and then across, you have many examples from robotics, lots of work around games, stories, art. I mean, so definitely we have a large array. Coding isn't just about kind of creating code, but it can be contextualized. But nonetheless, I want to try to make a pitch to think about also things beyond the computer. And electronic textiles is a really great example on where kind of crafting and computing, the kind of male-dominated domains of engineering, computing, merge together with kind of more traditionally female activities like crafting and sewing. And you can do, I mean, as complex and challenging things as you can do in robotics, and kind of introduce notions that computing isn't just on the screen, it's variable, portable, and expandable in different ways. And I want to make a different pitch even for the kind of competitions we have. We can think about access, activities, and communities. So we can create new communities. It doesn't have to be robotics competitions. We can create crafting communities around computing, like we did earlier this spring as part of the Pan Hackathon called Stitchfest, where people were designing variables, like a variable interface for the popular game Flappy Bird. And the reason why I'm telling you this, obviously this is beyond, I mean, it's on the college level. PanApps is actually opening up the registration. If you have high school students or college students who are interested in participating, have them apply. It's still open for 2 more days. It's also open to high school seniors. And if they get selected by the PanApps team, they get a free trip to Penn, housing and food, everything taken care of, and the opportunity to create great prizes. But it's meant intentionally. Stitchfest is within PanApps a smaller piece. So I want to wrap up by kind of looking on why we kind of needed code connected. I draw an analogy to urban planning, and which is, I think, probably very relevant with what we observed with American cities in the 60s and 70s. And people realized if we wanted to revitalize cities, we needed citizens to give a voice in what happened. And I think likewise, if we think about the digital public as a space, then we also need to give kids and all the members a voice in order to participate. And I think Jane Margolis called this, for that reason, the civil rights issue of the 21st century. So in closing, if you're interested in these ideas, there's a book coming out in 3 days, which has a more expanded version on why programming to learn and why code needs to be connected. Thank you. Yeah. I saw your hand go up. Thank you.
I'm curious in your research with Scratch if there was any way to delineate the students that came to Scratch because they were doing Scratch in their classroom versus those who just wandered in by free choice.
No, with the random sample, this was done. I mean, we got the back-end data. We didn't distinguish between those. But I would suspect that there is a great difference. I mean, Mitch is very fond of showing often that there is one project in which 30 people participate, the star formation, which often indicates that one class is working on exactly the same project, that there's very little personalization, and you can see it this way. In the kind of data, big data analysis we did, we could not distinguish this. And we also don't have any information about the ethnic makeup, because that information is not collected. So we are right now conducting a diversity analysis with web crawlers, because we only can go in from the public end. I think this is kind of important when we create these online communities, whether it's Kodu, Scratch, and there are many others, to kind of not live under the illusion because everybody can kind of go onto the site, that it's easy, to join the community, which we know actually many students in class don't want to go online because they feel not part of this community. But then also for us to think about on what kind of efforts we need to do in order to kind of create a deeper outreach. So it's not just about participation in the broad sense, but also in the deep sense, so that the kind of programming projects you become involved in are as sophisticated as those of others.
Hi, my question is also about the Scratch study. You had browsers and creators, and you said the browsers were defined by not leaving a trace. I was wondering if you could clarify, is it possible that some of those browsers created projects but just didn't share them?
Very good question. So as you saw from the data, the study was conducted in 2012 under Scratch 1.0, where people essentially were creating their projects offline and then uploading them. 2 years ago, we introduced Scratch 2.0, where now, I mean, you can also create online, and we're just in the process of collecting that data and conduct a comparable study. Because yes, it is very possible, we know that from talking to individual Scratchers, that many kids create programs which they never bother to put up, I mean, for a whole host of reasons, because they think it's not finished, it's not perfect enough, they don't want to share. So yes, we only capture a certain slice with kind of that kind of analysis and leave out others, school students as well as those who do not upload their projects.
Hi, I'd love to know from that 23-year-old video what those kids are doing now. Do we have any idea, has there been some longitudinal work about, if we do this stuff in junior high, what are these kids doing 10 years from now in their life, in their career? Did it matter? What do we have on that regard?
I asked myself this very same question because IRB regulations weren't as strong as you could see. The names of kids were identifiable. And Abigail, I know actually what her last name is. She's now an art instructor in college in Chicago, not far away from here. I haven't followed up with the other kids. I have done a more extensive 4-year study where I had kids participate in multiple of these projects every year. And they started out as apprentices, as third graders, coming twice into a classroom and looking at the design projects other kids have done for 10 minutes. But they knew in the coming year they would be joining a software design team. This was a school which had mixed grades, 4th and 5th, 2nd and 3rd together. So the 4th and 5th graders were always staying together for 2 years. So the students then designed, together with more experienced students, the 5th graders, the software, and then in the following year, in their 3rd year, became design leads of their own. And we found, and then even in 6th grade, they continued designing. So this is the only longitudinal study we have of this type of project, repeated several times with the same students. And one of the interesting findings we have from students that they actually think their understanding of programming goes down. They think actually they become less capable over time. And it was very shocking to me in interviews because when I looked at the programs they had created and the code, their sophistication of code definitely had gone up. And I think what happened over time that they just became more cognizant of the complexities of what goes into programming. One experience, what do you really know what's going on? But if you have done 4 or 5 projects, each lasting 3 months, dozens of hours, I think you have a much better sense of what you can create, what your limitations are. So that is the only evidence we have, in terms of what happens if you do something like this, not just once as part of a project, but as part of a school culture over 3 or 4 years. As to the students, nowadays on the internet, I'll try to find out what happened to some of the others, because it was a very unique project, as you can imagine, in the late 80s, where computers were not present at home, only in school, for kids to participate in such a study. Yes, here.
In order to increase diversity, I was wondering what your opinion was about making computer science or these computer classes a required class. We have a lot of female participation in, and success in algebra and math and science, but those are all required, even foreign language required for 2, 3, at least 4 years. But all of the classes that I teach are optional. So I wanted to get your thoughts on, if you made it a requirement, would that kind of help to stimulate diversity?
You just answered your own question. Of course it will. And I mean, you can see this in other countries like Israel, and I mean, in the UK, it's just starting once you have it a requirement when everybody has to participate. That doesn't mean everybody gets a rich experience, and we know that from the work 20, 30 years ago when we once had very widespread implementation. But we also know from that work that there was a much more larger number of women interested in computing. So whether you believe or not the pipeline argument, I tend to think it more about a network. People talk about the leaking pipeline from K to 12 into computing. It does make a difference. And when we think about broadening access to computing, I think what NSF has done in the last 10 years, they have actually focused just on the college pipeline. They didn't want to do K to 12 early on. And they realized they will never get the numbers up if they just kind of come at the end. You really need to create a broad pool like you do in algebra and other areas. And then I think you can decide. Now, what implications does this have? And I think that's a discussion which is happening right now on the state as well as national level. What kind of courses do we have? Is the AP courses the end for all? So I think curricula like exploring computer science, some of the activities which I show you for the elementary school level, where it's not just about learning concept structure, but where it's done in a more integrated way and a more applied way, will kind of create, the opportunity for students to see there is more to programming than what their kind of fairly narrow visions had. And then, once you can make an informed choice, whether or not you want to participate, then, you can also go into AP and other parts. So yes, and schools are the place, because it's called compulsory schooling, where kids show up every day, more or less. But more or less with their minds too, I know, so, yeah.
I have a question about what are we going to do as far as getting together with industries to help bring more females and more diversity into the schools. You mentioned earlier about sewing, and I guess the thing that comes to mind is when we think about programming, we already know that it's a male-dominated world. And even here, and I loved, UTI for showing us everything, but we go into automotive. And one of the questions that I asked there was, I know that a lot of females may not be interested in working on cars, but how can they know what else they can do with computing in that particular industry? You mentioned sewing. My daughter, who I raised to work on computers, wants to work into the fashion industry. And I know that there's a way that we can marry that into computers. I know that they have applications, which she's discovered at the college level, that allow you to fit clothes on the models. And there are more types of software that can be developed that could help transition girls with things that they already love and marry that to computing in some way. Same way we do with the medical field, and we show them how computers can be used to actually perform surgeries nowadays.
Mm-hmm. Yeah, so I showed to you the, many of you are familiar with the LilyPad Arduino, and I was kind of, sad to see in all the workshops which were here that a lot of stuff is mostly on the screen, and that we need, also on that level to kind of create different examples. So for those of you who don't know, the LilyPad Arduino is a microcontroller. It's actually functionally equivalent to the Arduino, except it's customized for sewing. And so you can create your own clothes with conductive thread, and then, make them interactive. And we have actually designed curricula pre-AP where you can show how to integrate computational thinking processes and concepts in a very similar way as you would do in a game design or other curriculum. So it's possible to do this. And what this really taps in, it's not just fashion, it's also wearables. And that is really, I think, one of the biggest topics in the industry. I think, so you have that as example. There is printed electronics, paper-based computing. You can work with all kinds of materials and which have kind of different trajectories into very different kind of industries. I think as much, we're kind of focused on application of games, simulations, and other aspects, we need to also broaden our repertoire and even go into the art domain. Media arts, in the arts area, computing is one of the biggest push for kind of new designs and interactions. So I want to just show you, I showed you the Stitch Fest because it's a very typical hackathon. There's about, believe it or not, 1,200 kids coming for 48 hours. They don't sleep. I slept. I went home for a night. And they kind of designed actually wearables. And we were actually able, just by suggesting a different theme, to more than double the number of women who came to Stitch Fest. Because we were promoting not just a software hack or a hardware hack, but something which was more applied and where you could kind of wear and do things with. So we also made it more collaborative. We asked people to share the content of the hack boxes. We had them all in a communal space. And that was really important to kind of create a different atmosphere. So all those events and activities we have created to promote coding, and hackathons are there a gazillion, we can also change the structure and activities of these to broaden participation. They're not cast in stone. And that way, we can also open up the doors to different groups of people who might not be interested to design a homework machine which solves your math problem and then handwrites the solution, which was the winner of Pen Up Spring 2014. It was a great hardware hack. But who want to kind of design maybe, clothes for babies who measure temperature or kind of do other things around it. Yeah?
Yasmin, thank you for your presentation. A lot of us idolized the work that was done in the 80s, and I myself was a child of Logo in the 5th grade. So I ask you, what are some of the top reasons why that movement didn't stick in schools or in the community, and what can us who are obviously working on this right now, what can we do, what advice would you give us to make our work stick?
Oh, great question. I asked myself that too, because in 1980, I came to the United States. For me, this was the golden land of promise where computers were in schools. My home country, Germany, teachers actually refused to bring computers into schools, so I had no opportunity to study this. And so I was here at the cusp in the late 80s when Logo, Basic, Pascal, those were the big battles which were fought, were everywhere. And then suddenly, beginning 90s, people decided this wasn't needed anymore. What happened? Well, number one, floppy disks and CD-ROMs came around. And you had an interface which you interacted through the computer. You just needed to slip in something. Why bother programming? The things you saw, Abigail, she programmed literally every single pixel on that screen. The code wasn't that complicated, but everything on that screen had to be programmed. You didn't need to do this anymore. So the need on how we thought about interfacing, interacting with the computer went away. Secondly, I thought there was a real teacher issue. Many teachers did not feel comfortable teaching computing. And also computing was not connected. It took place in a computer lab, and today it also takes place in computer labs. There was one room, at the end of a long hallway. Once a week for 45 minutes you would go there. And when Easter came around, you would program the Easter bunny to jump around. And when Christmas came around, you made a Christmas tree. And then you would go back to your regular classroom. So the other reason was it was not integrated. People thought what was happening with programming had nothing to do with what they were doing in teaching and reading and writing, with mathematics and science. It wasn't integrated. And it also, honestly, most kids never learned any serious programming. They learned some little sample programs. There was never anything extended like you saw in the fraction games. Kids spent weeks on designing these kind of games and interface, and it was integrated in the rest of the curriculum. You saw advertising, propaganda unit, you saw the art teacher, you saw story writing. There was extensive story writing. So all of these things became part. And that's why I'm arguing, number one, especially in the early K to 12, we need to think about integration, because there is no room in the school day to just carve out another niche. Number two, we need to think about meaningful projects, because just teaching code for the sake of coding will become an academic exercise. And most kids, and you know your students, aren't really that interested in it. They carry these very strange conceptions. Computing programming is not for them. It's something very weird people do. Well, I mean, and it's even with the electronic textiles. Truth to be told, nobody knows how to sew anymore. But even among the high school students we work with, it's deeply engendered that the girls are good at sewing and the boys are good at coding. Where does this come from? There's no empirical evidence for that. So we need integration, we need to make it personal, and I also argue we need to think about it social, because for kids today, their life is in the digital public. And I think we can use coding as a way to create more connections, to make transparent what happened there, what the algorithms are, which drive, the interaction and control, what you see and what you do. That doesn't mean that everybody needs to become a computer scientist who will design some of these systems, but I think you begin to develop a deeper appreciation and a better understanding on what is important, what is hard, and what is easy, that prepares you for citizenry. Did this answer your question? Yes. Good. It was a long answer. Yes, over there?
So one of the communities that can be built around programming is a community amongst programmers. So, Stitch Fest, Girls Who Code, etc. But there's also the community that develops between the producers and the consumers. And there's a certain amount of that's facilitated, for example, by the Scratch website, where you can like a project, you can download a project and use it. Excuse me. But I think the more significant that connection between the producers and consumers drives the producers to be more motivated, because they know that it's going to be consumed by someone. Is there anything that's being done to increase that feedback between, to build that community between the producers and the consumers, and to make that relationship, to make that connection between the producers and consumers, and to improve the feedback that is given from them?
Yes, if you go onto the Scratch site and look for Collab Camp, Collab Challenges, we actually did a number of interventions to invite people in to not only produce, but also to provide feedback and to become engaged in the community. Because we noticed, as you saw from the data, that not everybody in the community participates, that we actually have a pattern which is very similar in a lot of massive communities, including the MOOCs, the massive online courses. We have about 5 to 8% who are heavily engaged, and the rest is kind of flat. And so we try to figure out if we can do, kind of initiate the models which kids self-organize, but we kind of orchestrate, and we can model what kind of constructive feedback looks like. And that actually worked really well. And you can also kind of set up your own Collab camps or Collab challenges. You don't need to, so you can kind of leverage the connection with the community, but kind of do it in your classroom, and then model as a classroom teacher what actually feedback and commenting would look like, because it makes a big impact for the kids to see what a kind of constructive, productive way is to interact with others. And since on Scratch, everything is about liking and getting your project on the top page, you can kind of support this in very instrumental ways, and having students not only like and comment all their projects. Okay, one more or?
Okay. Last question.
Hello, I'm a computer science and computer programming teacher in South Florida, Miami area. Senior girl came to me last year, a year ago, and told me she was very interested in taking my computer programming course, and she had been to a counselor to rearrange her class schedule, but the counselor told her that computer programming was only for boys and she couldn't take the course. And I thought it was kind of interesting, and this wasn't like 1970 or something, this was like last year. And so she graduated from high school this year, went off to Sarah Lawrence College and wants to study engineering at Columbia. But she was disappointed that she couldn't take a computer programming course in my high school. My question is this: what exactly would you say to that counselor if you were in my shoes as a teacher? Now, and bear in mind, this counselor was not a white male. This counselor was a Hispanic female who gave her this advice and told her this. So I have a 90% minority school, 90% Hispanic. What would you say to that counselor specifically?
Oh, I could say many things, which I cannot say. But I want to, direct you to the fantastic work which Jane Margolis and Joanna Goda have done on exactly this topic, because they realized it's not just the students, it's not just teachers, it's also counselors who are really, gateways into computer science. And as long as we don't make all of these coordinate, we'll never have a chance, because that student, even though she was interested, didn't get supportive. So I think it's very important to tell the counselor, that it's very possible, and there's no reason why girls can't program. It's one of the great, every job in some aspect or another will involve IT, whether you use it or whether you make it. And the counselor will soon learn, you will tell her that this will become part of the curriculum. It will no longer be an elective, and then things have to change. But I think, Joanna and Jane's work in LA Unified has really paved the way to understand, A, what happens with counselors, what are their challenges and issues in understanding this topic, and then also, B, what you have to do in order to overcome these challenges.
Computers for counseling. Or counseling for counselors for computing. They have a pamphlet. Visit the booth. Great minds think alike, Joe.
Yes, and they also have great recommendations if you want to do competitions on how to reach, or they just posted a number of recommendations too. So sometimes telling is better than doing.
Absolutely. Thank you, Yasmin. How you doing? Kodak moment. That was an interesting, informative, and inspiring presentation. K-12 teachers, I want to tell you that there are people in your school that you really need to form relationships with. The counselor is one of them. So do that. And then the other people who run the school would be the custodian and the school secretary. So I'm sure all of you took away a pearl of wisdom from Yasmin's session, and I hope it really kind of forms your day for the rest of your stay today.